So I'm not sure if your question about polarity is just you don't understand polarity, or you don't understand this question here that asks you to use polarity in order to figure out if something is going to dissolve. And these two things are pretty well related, so I am going to explain that polarity, just the basics of what you asked, but I'm going to do that in the context of some of these examples here at the top of page 5, so that maybe even if you didn't need help with all of this, then you should be able to get a little bit more done in your packet. So, coming over here, telling if something dissolves is either going to be an ionic compound or a polar covalent compound. Those are the only type of compounds that will dissolve in water, specifically, because ionic compounds are superpolar and polar covalent are, polar. It's only non-polar compounds that do not dissolve. So, ionic compounds are easy to identify by looking at the periodic table, what kind of element it starts with. If it starts with a metal, it's ionic. If it's all nonmetals, then it's covalent. So, look for the metals at the beginning of the formulas on these compounds here. And you should find 3 ionic compounds where that's all that you got to do is, once you figure out that they are ionic, you know instantly they will dissolve in water. Now, if it's a covalent compound, then we have to make sure it's a polar covalent compound, because only polar covalent compounds dissolve. If it is nonpolar, then it won't dissolve. So these are the 2 questions that we have to be asking ourselves in order to tell if something is polar. We're looking for lone pairs on the central atom, like here in this NH3, how we have these dots in our Lewis dot diagram on our central atom. That's important. That's the only place that they matter. So this would be yes, it is polar, and it would dissolve in water. And then over here are the outer atoms different. This is CH3Cl, and you can see that we've got one of these outer atoms, not the central atom, but the outer atoms are not all the same as each other. So that would once again be a yes, this is polar and would dissolve. So those are the 2 questions that you're asking yourself to tell if something is polar, and these are the 2 best, simplest examples for that kind of thing in order to kind of understand these questions a little better. Looking at the examples from your packet that ended up being covalent was our CH4. C was a nonmetal, and so it is a covalent compound. And when we look at this, our central atom is our carbon, and there are no lone pairs on our central atom. And so we can't instantly say this is nonpolar. We have to answer no to both of them for this to be nonpolar, or one yes would instantly make us polar. So we answered no to our first question. And looking at our outer atoms, none of these H's are any different than the other H's. So this is another no. So this is a non-polar compound. Means it won't dissolve. Another covalent compound that we saw on that page is I2. And sometimes with these diatomics, like I2, Cl2, N2, H2, any of them, it's a little bit harder to do this polarity question because this first question is asking about a center atom, and there is no center atom. So what I kind of think about, the center of this molecule is this bond here. And so that center of our molecule does not have any lone pairs around it. It can't. So any diatomic is automatically going to be a no here. But if you just look to the center of the atom, there's no lone pairs, no dots in the middle. And then the outer atoms, thinking of that as our center, helps us realize we're looking at these outer atoms, and these are the same. They are not different. So once again, and then our last covalent compound on page 5, at least, is C6H12O6. And this one, once again, if you're starting to try and find the center atom here, technically all of these carbons want to be in the center, and so they're all going to kind of share the center. And so looking at all those carbons, there's no dots, so there's no lone pairs. And as we look at these outer atoms and even kind of outer groups attached to them, they're not all the same. There are some different groups around that center string of carbons. So that means that this is one of the first that we said no and then yes. So this is polar, which means that it will dissolve. So hopefully that helps you understand polarity and how that's going to affect our dissolving. Let me know if you have any other questions.